we are looking at quadratic equations. So this is our lesson number 2. In lesson 1, we looked at how to solve quadratic equations in factored form. For example, we had an equation like x into x minus 1 equals 0. And we said that we all know that to get 0 in multiplication, one number must be 0. Like if I have 4 times 0, I can get 0. Or if I get 0 times 4, I can get 0. So in order to get 0, when you do multiplication, one of the numbers must be 0. It's like if I say that A times B equals 0, then it means that maybe A is 0, such that I get 0 times B to get 0. Or it can be that maybe it's B that is 0, so that I can get A times 0 to get 0. Or maybe both of them can be zeros. It can be that maybe A is 0 and B is 0. So that if I get 0 times 0, I will get 0. So those are the ways of getting 0 when you do multiplication. Now, since we have got x times x minus 1, it means that maybe x is 0, so that I can get x times x minus 1 to get 0. Or x minus 1 is 0, so that I get x times 0 to get 0. So that's why we said that we can say that x equals 0 or x minus 1 equals 0. But then we need the value of x. We need the solution to this quadratic equation. So it means that, okay, x is 0. But then if x minus 1 equals 0, it means that x minus 1 plus 1 equals 0 plus 1. And x minus 1 plus 1, that is 0. So x equals 1. So it means that the solution to this equation is that x equals 0 or x equals 1. These are the solutions to this quadratic equation. Now, let's get another review that we looked at last time, then we begin our lesson of today. We can also have number 2 in case, let's say, 2x into x plus 1 equals 0. So the same applies. It means that to get this 0, maybe 2x is 0, or maybe x plus 1 is 0. So if 2x equals 0, and we can divide on both sides by 2, it means that x equals 0, because 0 divided by 2 equals 0. Then, if x plus 1 is 0, then we get x plus 1 minus 1 equals 0 minus 1. 1 minus 1 is 0. So x is equal to 0 minus 1, which is negative 1. So the solutions to this quadratic equation will be that x equals 0 or x equals -1. Is that okay, everyone?
Yes.
Okay. Now, let's begin our lesson of today. We are going to get more examples of solving these quadratic equations. Remember, first of all, we are solving these quadratic equations by factorization. We are solving by factorization. Okay, now already what we looked at last time, like number 1 and 2, they are in factored form. But now let's look at the lesson of today. In case we are given quadratic equations that are not in the factored form, how can we solve them? So let's have this as example 1. So we say that solve the following quadratic equations. Solve the following quadratic equations. So let's have A as n squared minus 16 equals 0. Then we can have B as 121 minus a squared equals 0. Let's have C as 9x squared minus 4 equals 0. Let's have D as 4r squared minus 100 equals 0. And E as 128 minus 2b squared equals 0. Okay. Like I've told you already, please don't worry. Do not write right now because I'm going to send you everything that we are looking at today. You can take your time and copy in your yellow notebook. So you just follow. And in case you don't understand, you can ask. So let's get the solutions. We begin with A. We have n squared minus 16 equals 0. Now, I want you to remember in Matheum 2, when we were factoring quadratic polynomials, there is where we need to factorize these quadratic polynomials using the difference of squares. Difference of squares, where we said that a plus we said that a squared minus b squared equals a plus b into a minus b. Now, I want you to relate this identity with our question number 1. We have n squared minus 16 equals 0. Now, I want you to look at that as if we have n squared as a squared minus 16. 16, we can write it to be b squared. Just look at that. We are going to say that, okay, n squared is n squared minus 16. How can we write 16 to be squared? Yes? Can we say 4 squared? Because if we say 4 squared, it will still be 16, because 4 squared is 4 times 4, which is the same as 16. You understand that?
Yes.
Okay. So n squared minus 4 squared equals 0. Now we have got a squared as n squared and b squared as 4 squared. Now we can use this identity. So we say that, okay, so we have n plus 4 into n minus 4 equals 0. So I believe that is okay. Just relate it to this identity. A squared minus b squared equals a plus b into a minus b. So n squared minus 4 squared is the same as n plus 4 into n minus 4. Now, this will be the same as what we looked at last time. So we say that we have got, in order to get this 0, it means that maybe n plus 4 is equal to 0. All n minus 4 is equal to 0. So it means that if n plus 4 equals 0, then we have n plus 4 minus 4 equals 0 minus 4. And this is 0. So n is equal to -4. And if we have n minus 4 equals 0, it means that we have n minus 4 plus 4 equals 0 plus 4. And this is a 0. So n equals 4. So the solutions to our equation are that n is equal to -4, or n is equal to 4. Do you understand that?
Yes.
Okay. Now let's look at part B. In part B, remember, we have got 121 minus a squared equals 0. So we will say that, oh, how can we get 121 if we square? We know that 11 times 11 equals 121, right? Is it okay?
Okay.
Okay. So then it means that, okay, 121, we write it as 11 squared. Then we already have a squared equals 0. So we say that 11 plus a into 11 minus a equals 0. And in our next step, we say that 11 minus a is equal, 11 plus a is equal to 0, or 11 minus a is equal to 0. Then it implies that this 11 will come this side in order to get a. So a is equal to -11. Then here we say that since we have 11 minus a equals 0, it implies that, okay, we can have 11 minus 11 minus a equals 0 minus 11. So minus a equals minus 11. So a equals 11. So it means that a equals minus 11 or a equals 11. Is it okay?
Okay.
Okay.
Okay. Let's get part C. Remember, in part C, we have 9x squared minus 4 equals 0. Okay, so like how we have done part A and part B, we will simply say, okay, so 9x squared is 3, 3 squared is 9, and x squared is x squared. So we say that this is 3x squared. Say that 3 squared is 9, x squared is squared, that x squared. So minus, what should I write? How can I write 4?
2 squared.
Very good. 2 squared, that is equal to 0. So what should I write in the next step? Yes, just as the same as this part of part B.
3x plus
Hmm?
plus 2
Very good. Into,
times 3x minus 2
very good.
equals 0.
That's good. So we say that 3x plus 2 equals 0, or 3x minus 2 equals 0. So if we solve the first part, we say that we have 3x plus 2 equals 0. So we take this 2 to go this side and have 3x equals negative 2. We divide on both sides by 3. This goes and we have x equals negative 2 out of 3. And then for this part, we have 3x minus 2 equals 0. So we take minus 2 to go this side, such that we get 3x equals 2, and we divide on both sides by 3. This goes with this, and x equals 2 out of 3. So this means that our solution is that x equals negative 2 out of 3, or x equals, let me write it this side, my page is finished. All x equals 2 out of 3. Okay, so for part A, let us have x squared minus 3x minus 28 equals 0. And let's have part B as k squared plus 12k plus 36 equals 0. And for part C, we will answer it together as kind of practice. M squared minus 16m plus 64 equals 0. Okay, let's get the solutions very quickly. And we begin with part A, where we have x squared minus 3x minus 28 equals 0. Now, this one is just in the standard form of a quadratic equation. But I want you to remember that we even learned about this in Mathayom 2, when we were factorizing polynomials like x squared minus 3x minus 28. We did something like this already in Mathayom 2, but only that now we are just adding equals 0 to make it a quadratic equation. The other time it was a quadratic polynomial, but now it is a quadratic equation because we have equals 0. Just that difference, but we already looked at this in Mathayom 2. Now, you see, we have x squared minus 3x minus 28 equals 0. You need to think, which two numbers can I multiply to get negative 28? A number times a number, I get negative 28. But also, those numbers, two numbers, I can add them to get negative 3. You see that? Think about that. Which two numbers can you multiply to get negative 28, but add them to get negative 3? You can think, okay, how can I get negative 28? Maybe I can have 1 and negative 28. Maybe I can have negative 1 and 28 in order to get 28. Maybe I can have 2 times 14. Let's say negative 14, or negative 2 times 14. 3, no. I can have 4 and negative 7, or I can have negative 4 and 7. These are the ways how I can be able to get negative 28. But then, how can I get 3? Let's see. How can I get negative 3? 1 plus negative 28, I'll get negative 27. That is not 3. 1 plus 28, I'll get 27. No. 2 plus negative 14, I will get negative 12. No. Negative 2 plus 14, I will get 12. No. 4 plus negative 7, I will get negative 3. Oh, yes. You see that? So it means that the numbers are 4 and negative 7. 4 times negative 7 is negative 28. And 4 plus negative 7 is equal to negative 3. Have you understood that, student?
Yes.
Yes, this is quite easy. We finished this already last year. Okay, so it means that I will say that I have x, this is positive 4, x plus 4 into x, this is minus 7, minus 7 equals 0. So already I get back to what we finished already, and then that's so easy to get the solution to x. So x plus 4 into x minus 7 equals 0. Just only that. And if you need to check that really this is correct, just get x plus 4 into x minus 7 equals 0. If you get x times x, you get x squared. If you get x times negative 7, you get negative 7x. If you get 4 times x, you get 4x. If you get 4 times negative 7, you get negative 28 equals 0. x minus 7 plus 4 minus 7x plus 4x, I get minus 3x minus 28 equals 0. You see that this one is the same as this one? Do you see that?
Yes.
Yeah, so that's how you do it. You can even check and see that your answer is correct. Okay, so here I can say, okay, x plus 4 equals 0, or x minus 7 equals 0. If x plus 4 equals 0, what is x, student?
-4.
Very good. And if x minus 7 equals 0, what is x?
7.
7. So it means that our solutions are x equals -4 or x equals 7. Okay. Now let's look at part B. In part B, we have k squared plus 12k plus 36 equals 0. Now, also think, which two numbers can I multiply to get 36? And I add them to get 12. A number times a number equals 36. A number plus a number equals 12.
6, teacher.
Oh, very good. 6 and 6, right?
Yes.
Okay. So it means that I have 6 times 6 is 36, and 6 plus 6 is 12. So what do I have? K plus 6 into k plus 6 equals 0. So what next? Yes, I say that
K plus 6
equal 0,
0.
all.
Oh,
K plus 6 equals 0.
Okay, so if k plus 6 equals 0, what is k?
minus
Minus 6
And if k plus 6 is equal to 0, what is k?
-6.
minus 6.
So it means that the value of k is minus 6. Okay, now we try together part C. Part C, where we have m squared minus 16m plus 64 equals 0. So let's think, what two numbers can I multiply to get 64? But when I add, I get negative 16.
Minus 8.
Minus 8 and minus 8. Okay, minus 8 times minus 8. Yes, it is 64. And minus 8 plus minus 8, I get minus 16. Very good. That's correct. So what should I write?
M minus
8
8
into
into M
minus,
minus 8.
okay, equals 0. So
m minus 8 equals 0,
Mhm.
or m minus 8 equals 0.
So it means that m equals,
M equals 8.
and also here m equals
8.
8. Okay, so that is our answer. And even if you need to check, like I told you that if you multiply two numbers like A and B to get 0, it means that maybe A is 0, or maybe B is 0, or maybe A and B are zeros. So you can see that if we have M equals 8, and also here M equals 8, it means that A is 0 and B is 0. Because you get M minus 8, you get 0. Because M is 8. 8 minus 8 is 0. Also here, 8 minus 8 is 0. So 0 times 0 equals 0. So that's how you can solve these quadratic equations. And I told you that we did this already in Mathayom 2 when we were factorizing quadratic polynomials. So there is something that we are going to look at on Friday, but I will give it to you as homework. I'll give you one number to think about it, and then we can discuss on Friday. If you have 2x squared plus 5x minus 12 equals 0, what is x? Think about how to solve that, and we can talk on Thursday. Now, I want to tell you your homework. Do you have your book there, student?